So in this video, we're going to start out by talking about some logical operators. When we want to do conditional statements, sometimes we want to compare two things at this kind of same time, right? We want to say, hey, we want this and this to be true, which, by the way, comes out to be true if they are both true. Sometimes we want to say, we want either this to be true or this to be true. So that's where we have this and or operators. Binary operators connect two Boolean expressions into a compound Boolean expression. So we can say, hey, this and, or we can say X or. That's what it kind of looks like. We can also use the not operator, which is a unary operator, and it reverses the truth of its logic, of the Boolean operator. So with that being said, if we use the not, and we say not true, this equals false. Not false equals true. Because it reverses the truth of its Boolean operand. So the AND operator, when we do this, what you might find with the AND operator is there's only one way something can be true. Otherwise, it's always going to be false. And the only way it can be true is if we have a true and a true. Everything else will always be false. False and a false is false. False and a true, either direction, is always going to be false. What's funny about this is you're going to find that with the OR, it's just the opposite. Everything is true except this one false. So if we say false or false, and by the way, they're using the word and here, not like the and of the operator. They're just saying if you have two items on, so you're saying A or B, right? So this is the A and this is the B, and all these are ORs. What happens, right? So false or false will always be false. Everything else is going to be true because you only need one true out of all of them. So you can have as many as you want. As long as one of these is true, then the entire statement is true. So that's why, because this is true on, so the first one or the second one, they're going to be true. And also both being true, at least one of them is true. So that, again, that means that it's true. Now you might have said, but Professor Waits, if that's the case, if we know that only one of these has to be true, then why would we care if the first one is true if any of the other ones are true? Because it will automatically in the OR statement be true. And that, my friend, is what's known as the short circuit evaluation. And it happens for both ands and ors. So let's go back to the ands. Let me erase this for a moment. What we know is that all statements have to be true to get a true. So any moment that it hits a false, it can stop evaluating. It doesn't need to evaluate anymore. It will stop. So as soon as it hits that first false, it'll say, oh, I don't care about the rest. Blah, blah, blah. I already know that this is going to be false. In this case, it's going to say, oh, false. Okay, we're good. We're good. It's going to go on to the next one, and it's going to say, oh, true. And it's going to stop right there. If there were more statements beyond this, it wouldn't matter. It's going to say, I don't need to go any further because I know it's false. In this case, again, as soon as it hits that first false, it knows that it's false. So in this statement, true and true is why it can turn true. So let me erase and talk through this through one more time. All right. So as the Python interpreter is going through, as long as it finds a true, it will keep going. As soon as it finds a false, it will stop. And it will never, never look at the rest of um, the expressions. If it finds a true, it will keep going. Well, it's just the opposite with or. Again, let me erase this for a moment. Lot to erase here. Give me a moment. All right, got it all. With or statements, anytime it finds a true, it stops because it knows that that statement will now be true. It doesn't have to keep going. So if it finds a false, it will continue to keep going. But if it finds a true, it stops because that evaluation is now, that whole statement is always going to be true. So in this case, it says, oh, false. Okay, I need to keep going because I don't know yet if this is true. So now it will go and look and it'll say, oh, okay, this one was false as well, so it means it's false. There's no more to check, so I won't check. In this, it goes false. Okay, don't know yet. Got to keep going. It hits the true and it says, yes, it's true. Actually, I shouldn't put not put an X there. It's saying, okay, this is true, so now I know it's true. If there were more statements, it would not continue on because once it hits one true, it knows that entire statement is true. When it evaluates this one, it hits this first true and says, okay, don't need to look at the rest of them because it automatically is true. Same with this one. It wouldn't need to look at this other true because one true means this entire statement is true. So that is what's known as short circuit evaluation. And we can word that a little bit by saying for or operators, if the left operand is true, compound expressions are always true. Otherwise, evaluate right operand. So in other words, if the operand that it's doing first is a true, then it's true and doesn't need to go any further. If it's not, it needs to keep going. The opposite occurs with the and statement. If the left operand is false, compound expression is false. Otherwise, evaluate the next operand. With the not operator, it takes one Boolean expression as an operand and reverses its logical value. So sometimes it may be necessary to place parentheses around an expression to clarify what you are applying the not operator to. The truth table for the not operator is pretty simple. As we said, if it's true, it's going to evaluate as false. If it's false, it's going to evaluate as true. All right, so we're going to stop there. And when we come back, we'll start with checking numeric ranges with logical operators. I'll talk to you here in a moment. Thanks.